All right, let's talk about something that I'm sure many of you have run into. You've got this amazing idea for a smart device, a cool new gadget, but then you hit a wall. The hardest part. How do you actually get it connected to the internet? Well, today we're going to dive into a really powerful tool that makes all that complexity just kind of melt away. Let's get into it.
So, here's the game plan. We'll start with the big problem, the connectivity challenge. Then we'll meet our solution, the ESP AT firmware. We'll learn the simple language it speaks, see how it unlocks the whole Internet of Things, and even take a quick peek under the hood at customization. And hopefully, by the end, you'll be thinking about your next big project.
Okay, so first things first, let's talk about the real problem here. You've got a microcontroller, it's the brain of your project, right? But you want to give it a voice, let it talk to the internet. And if you've ever tried this, you know it is a huge leap. I mean, that's the dream, isn't it? Giving your little gadget internet superpowers. But how do you actually do it? How do you take your cool creation and plug it into the entire world? Yeah, that path is not always as simple as it sounds.
For most of us, this is what it actually looks like. It's a total mess. You're not just plugging something in. You're wrestling with this tangled web of low-level drivers, trying to manage a complex TCP/IP stack, handling Wi-Fi passwords, and writing hundreds, maybe even thousands of lines of networking code. Honestly, it's a huge barrier that can kill a fantastic idea before it even gets started.
But what if you could just skip all of that? What if there was a way to just bypass that whole nightmare? Well, this is where ESP AT comes into the picture. It is such an elegant solution that's designed to do one thing, and do it really, really well. Handle all that messy, complicated connectivity stuff for you.
The best way to think about it is like a universal translator, but for the internet. You just flash this special firmware onto a powerful little ESP32 chip, and suddenly, that ESP32 becomes a dedicated communications helper. Your main microcontroller, the one running your actual project, well, it doesn't need to know a single thing about Wi-Fi or Bluetooth. Nope, it just has to know how to send a few simple text messages. And this diagram here shows you exactly how clean this setup is. See, on the left, you've got your main controller, your host MCU. It's just sending a simple text command over a serial line. Then, in the middle, the ESP chip running ESP80 gets that command and does all the heavy lifting. I'm talking managing the Wi-Fi connection, dealing with the Bluetooth stack, all of it. Your main project is totally free to just do its job.
So, you might be asking, why go this route? Well, for one, it is incredibly stable and reliable. This isn't just some side project somebody threw together, it's built on Espressif's official battle-tested code. That means your device isn't just going to randomly fall off the network. Second, it's just so simple. You do not need to be a networking genius to use it, and that means you can get your project online in minutes, not weeks. And even though it's simple, it is seriously powerful. You get access to Wi-Fi, Bluetooth LE, TCP/IP, HTTP, even cloud services, the whole shebang.
Okay, so how do we actually talk to this internet translator? We use a language that's been around forever, and it's famous for being super simple: AT commands.
Just look at this. That doesn't look like scary C++ or Python code, does it? You can pretty much read it and guess what it does. This right here is a real, complete command that gets your device online. And what's it doing? It's literally telling the ESP chip, hey, join the Wi-Fi network names test with the password 12345678890. That's it. One line. And all the crazy complexity of scanning, authenticating, getting an IP address, all of that is handled behind the scenes by that single command. And this shows the conversation you have with the device perfectly. You send a command like AT plus CWJAP, and it replies back, okay, Wi-Fi connected, Wi-Fi got IP. You ask it for the time with AT plus CIP SNTP time, and bam, it gives you the current date and time straight from a network server. It's just a simple, predictable back and forth. And this language is surprisingly versatile. You've got commands that start with AT plus CW, that's for all your Wi-Fi stuff, then AT plus BLE handles Bluetooth. You can even make web requests with AT plus HTTP commands or connect directly to massive cloud platforms like AWS IoT with AT plus MQTT. It's a complete toolkit all through simple text.
So let's see how this all comes together, because this isn't just about connecting to the Wi-Fi in your house. This is about connecting your project to the entire global Internet of Things. This is where it gets really cool.
Okay, This right here is the magic moment. Check this out. On the left, in that terminal log, we see the command AT plus MQTP pub being sent. It's publishing a simple message, hello AWS, to the cloud. And then, on the right, that's a screenshot from the actual AWS IoT Cloud Console, where that exact same message shows up almost instantly. From a simple text command on your desk to a global cloud service just like that.
And I really want to drive this point home. This isn't some theoretical exercise. This makes connecting to industrial-strength, powerful cloud platforms incredibly accessible to everyone. The stuff that used to require complex programming libraries and authentication headaches is now just a few lines of text.
Now, what you get out of the box is already super powerful. But for those of you who like to tinker and want more control, ESP AT isn't a locked box. You can actually customize it and recompile the firmware to fit your project's exact needs.
Using a tool called Menu Config, you get a simple text-based menu that looks like this. From here, you can just go down the list and turn entire features on or off. You don't need Bluetooth for your project? Cool, uncheck the box. Want to add support for a file system? Just check it. This lets you build a really lean, optimized firmware that has only the features you need, which saves a ton of memory and resources. And the process itself is really straightforward. You grab the source code from GitHub, you run that configuration menu, you build the project, usually with a single command, and then you flash that new custom firmware onto your chip. So even this so-called advanced path is super well documented and accessible.
So let's wrap this all up. What does all of this actually mean for you and that next big idea you have? Well, it means that building really sophisticated cloud-connected devices is now totally within reach.
Here's the key takeaway. ESP8 is your shortcut. It takes the single hardest, most annoying part of IoT development, all that wireless networking stuff, and it just handles it. It lets you focus on what makes your project special, on what makes it unique. It lets you focus on your idea.
So, with a tool like this, all that crazy complex connectivity is now just a simple conversation away. The barrier to entry has been smashed. The tools are right here, ready to go. So the only real question left is, what amazing thing are you going to create?